So for naming binary molecules, I changed the title of the slide a little bit to naming binary covalent molecules, which is actually a combination of two nonmetals. So an example of something like that would be carbon dioxide or carbon monoxide, right? Because carbon is a nonmetal and oxygen is a nonmetal. Some binary covalent molecules just have common names. Some examples that are found in the textbook are CH4, which is methane, which is a component of natural gas. NH3, that's ammonia. It can sometimes be found in household cleaners like Windex, and of course H2O, which I think almost everybody's familiar with, which is water. But most of the time we're going to name binary covalent molecules, which again are a combination of two nonmetals using the rules that I have laid out in the next couple slides. So we're going to list the names of the elements as they're written in. They're going to be, the names of the elements are written in the order in which they appear in the formula. So if the carbon comes first, I name that first, and if oxygen comes last, obviously I put that last. And a prefix is going to indicate the number of each kind of atom. So you would have seen this previously if you looked at the hydrates, and we talked about a monohydrate, a dihydrate, a trihydrate, so on and so forth. So we use the same prefixes to denote the numbers of atoms in a compound. So now you might pick up on why it's carbon dioxide, because I have two oxygens, and then in CO this is carbon monoxide because I only have one oxygen. Some other rules. Number 3, it says if only one atom of a particular element is present in the molecule, the prefix mono is usually omitted for the first element. So, sorry, I have this little funny line here, but for CO, we wouldn't call that mono carbon monoxide. We drop that first mono, so it just becomes carbon monoxide. And you probably noticed here, if I skip right ahead to rule number 5, it says the final vowel in the prefix. So for in this example here, it would be mono, right? We drop that last vowel, before a vowel in the stem name. So instead of monooxide, it becomes monoxide. If I go back to number 4 here, it says here the stem of the name of the last element is used with the suffix "ide." So of course, oxide, fluoride, bromide, etc. And then for number 6, there's an interesting exception. It says compounds with hydrogen as their first atom do not use prefixes for either atom. So the suffix "ide", we still use that for the second atom. So if I was to think about what would be the systematic name of H2O, it's not dihydrogen monoxide. If I follow this rule, I use no prefixes. Do not use prefixes. So it would simply be hydrogen oxide. So this is just simply hydrogen oxide. All right, kind of an interesting exception there. So if we take a look at the problems that are laid out here, so let's take a look at these. So the first one says, what is the formula for carbon disulphide? Well, carbon is a nonmetal, so carbon's a nonmetal, and sulfur is a nonmetal. So I don't use a prefix for the first element since it's only there's only one of them, so I'm going to put carbon, and if there's two sulfides, so that means there's two sulfurs, the formula should be CS2. The next one, I have PCl5. What is its name? Well, the first element is phosphorus. Again, since there's only one of them, I don't say monophosphorus, so I must start with phosphorus. And since I have 5 chlorides, it would be penta, would be the prefix, so phosphorus pentachloride. So phosphorus pentachloride. And then it says here, give the name and formula of the compound whose molecules each consist of 2 nitrogen atoms and 4 oxygen atoms. Now, another rule is that we list the element with the lower atomic number first. So if I have 2 nitrogens, nitrogen has a lower atomic number than oxygen, so I'd put N2, and then I have 4 oxygens, so it would be N2O4. So if I have 2 nitrogens, it must be dinitrogen. And if I have 4 oxygen atoms, it would be tetra, but since the root oxide starts with a vowel, so instead of tetraoxide, I say tetroxide. So there we go. So not tetraoxide, but tetroxide. So this would be dinitrogen tetroxide. So that is how you name binary covalent compounds.